A quick tut to show you how to use JF matrix truss analysis. I'm going to do this HSC question here from 2009 on jfmatrix.com. Click on truss analysis. If you create an account, you'll be able to save your trusses if you don't need to. The diagram has 4 metre spacings horizontally and 3 metres vertically. If the dimensions were 30 or 40 or 50, you could just scale it. So these are nodes, members, and supports, forces, zoom in and out, move. We'll be using the truss analysis. So 4 metre spacings, 1, 2, 3, 4, 3, 4, 1, 2, 4, 1, 2, 4, 4. You can change your view to line view or back if it glitches and things disappear. So now I'm placing members using the member tool. Counting up 1, 2, 3. So you can also place your nodes just with the member tool. Press escape to break it. Okay, then we'll place our supports. We've got a hinge support, which is a pin joint at the right hand side, and a roller on the left hand side. Now roller Y means it can support a force in the Y direction, so it's a rolling horizontally, which is what we want. Roller X can support an X force or a horizontal force, which would be used for hangers. Place our forces, 12 kilonewtons going down. So these units are in kilonewtons, so nothing horizontally, and 12 in the Y direction. Here we've got to provide 7.5 vertically and 8 horizontally. So right and up is positive. And we change to truss analysis and click play or analyze. Initially it does the result, works out the resultants. So we've found 7.2 and 12.3 and 8. If we've got A, it will show you the forces in each of the members. Change to view, solid view, to make the view a bit clearer. I'll also do an example where we've got some hang style ones. So new model. No, I just won't save that. So in this example, we need to draw 1.5 meters. So I'm going to zoom right out so I can use 10, 15. So 10, and then 1, 2, 3, 4. There's 15, so that's 1.5. And that would be one lot of 15, 2 lots of 15. I need to zoom out. So one lot of 15, 1.5 meters, 2 lots of 1.5 meters, and then another lot of 1.5 meters. Change the view to line view, it's a bit easier. So at 1.5 meters, beam here. This next pair of beams, it's hard to see exactly where they're supposed to be, but they're redundant members anyway, so their angles are irrelevant. So all that's important is the angles of the scale from 1.5 meters to using 15 units on here we'll keep those angles the same. Placing a roller, but I need to choose roller X so it can support a force in the X direction for the roller at joint A, and a fixed joint at B. It's drawn like this, but it's a fixed joint, so it doesn't matter anyway. Placing a vertical load of 1,200 newtons, so that's 1.2 kilonewtons here to get the load window back up. So 75, 0.75 kilonewtons. And solving for the resultants, we have 3.45 kilonewtons here at A, 3.45 horizontally here at B, 1.95 vertically. Changing to analysis of the forces inside the beam show that, yep, sure enough, these were zero load members, and the HSC question asks us to find the force in AC. Changing the view to solid view to read it, 1.7 kilonewtons. Can be got just by analysing this one joint.